This number string talk was developed when looking at the mathematical objectives that students needed to know in order to multiply decimals. Using backwards mapping and the assessment guide, this is the problem that I chose to base my number talk off of. And here are the problems I wrote for the 5th grade math class.
And when you think you can solve it, you're going to give me a thumb, like a finger up, and if you can think you can solve it in 2 ways, you're going to put 2 fingers up. And remember, right now you're not going to raise your hand because we want to give everyone finger time. Okay, so here's your first number. If you think you know what goes in that number, can you whisper it into your hand? If you think you know what goes in the blank, can you whisper it to your neighbor? Can someone give me a quiet hand and tell me what number you think goes there? 10. You give, Carly, can you tell me how you knew that was a 10?
Because 6 times 10 is 60, and you have to get 60.
So you said in your head 6 times 10 is 60, and here you needed to get 60, so you need 6 times 10. Did anyone see it a different way?
Well, I knew that 4 times 60 is 240, and 4 times 6 equals 24, times 10 equals 240.
Okay. Yeah, that's it. 2 different ways to look at that. Okay, here's your next one. You think you know what goes in the blank? Can you whisper it to your elbow? And whisper it to your neighbor. And give me a quiet hand. What did you get? Yes.
100.
100. If you agree, give a thumbs up. Awesome. Can you tell me how you got 100? How did you know that so fast?
Well, I did it the same way that Carly did. I knew we had to get 600, and I just knew that 100 times 6 equals 600.
So you knew that 100 times 6 gave 600. So here's your 6, and here's your 100. If you agree with that, can you give me a thumbs up? Here's your next one. Thinking fist ready. Yes.
0.01.
0.01.
Because if you multiply 6 times 0.01, you have to get 0.06.
So 0.06 or 6 hundredths is the same as 6 times 100. Okay, now I want you to turn to your neighbors again and see if you can find a pattern or some sort of structure. Heads together. Gotcha. Okay. Can someone tell me a pattern they saw or something they noticed? Thank you. Lily.
There's a 4 in every problem, and a 6 in every problem, and a 0 in every problem, and a 1 in every problem.
Wow. So there's a 4, a 6, a 0. What's changing? 4, 6, zeros, and 1s. Same digits, but what's changing?
On the first 2, it's 10 times 100. It's like on the first one, the first problem we did, and the second problem we did, the difference is times 10.
Ah, so this is times 10 and times 100. Is that what
And
you're
it's
saying?
the same one for the bottom.
How's that?
It's divided by 100 for the bottom.
Am I dividing?
Well, you're at your times 10 for 1/10 times 1/10 equals 100.
1/10 times 1/10 equals 1/100. Ah.
The 6 and the 1 are changing its place value.
Ooh, changing. Can you explain? Tell me more about that.
So on the first problem, the one was in the tens place, and the 6 was in the tens place also. And in the second problem, the 1 was in the hundreds place, and so was the 6. And then on the third problem, the 1 was in the tenths place, and so was the 6. And then on the last problem, the 1 was in the hundredths place, and so was the 6.
Oh, wow. So here's your hundredths, here's your hundredths, here's your tenths, here's your tenths. Is that what you're looking at? Here's your hundreds, here's your hundreds, here's your tens, and here's your tens. Wow. Oh my gosh, Layton. That is really cool. You guys, on the count of 3, I'd like to give one clap for Layton. One clap. Ready? 1, 2, 3. Thanks, Layton.
Thanks to Mrs. Jones and her wonderful class for sharing their mathematical thinking.